All right, here we go. This is problem number 20 from Chapter 6 of the Holiday and Resnick textbook. So we've got this box of Cheerios over here. That's the yellow box. And a box of Wheaties. So here's the Cheerios, here's the Wheaties, okay? And we're given the two masses. So the mass of the Cheerios is 1 kilogram. The mass of the Wheaties is 3 kilograms. And they are accelerated across a horizontal surface by a frictional force of F applied to the Cheerios box. So the magnitude of frictional force between the Cheerios and the floor is 2 newtons. The Wheaties, it's 4 newtons. F is 12 newtons. We're trying to find the magnitude of the force on the Wheaties box from the Cheerios box. So system of objects, right? We've got 2 objects here, Wheaties box and Cheerios. So in general, usually when you're solving these system problems, you want to start by looking at the system as a whole. All right, so here is our system. This is Cheerios and Wheaties together. It's 4 kilogram system, right? 1 kilogram from the Cheerios, 3 kilograms from the Wheaties, right? And I see 4 different forces that are acting on this thing. There's our applied force F. That's 12 newtons, right? And then there are 2 frictional forces. There's going to be a force of kinetic friction from the Cheerios, slowing the system down, and then an additional force of kinetic friction of -4 newtons on the Wheaties. Okay? So I think those are all of the forces that are going to affect the system. Now, there are other forces here, right? There's the force of the Cheerios pushing the Wheaties, the force of the Wheaties pushing the Cheerios, but that's an internal force, right? Remember, when you look at a system, the only forces you put on your free body diagram are the forces that are external forces, forces that come from outside of the system. So this force here is an applied force. It doesn't say, maybe it's whatever, maybe it's the force of Roy, right? So that is an external force. And then friction comes from the table, okay? Now, technically speaking, there are 2 other forces. There's a force of gravity and a normal force, but because those can't cancel, we're not going to worry about them. All right, so what I can do now is I can analyze my system and I can go, oh, well, so the net force on my system is, well, it's the total of all the forces. So it's going to be 12 plus -2 plus -4. So you get a total of 6 newtons of net force. And so that means that the acceleration of the system is net force of the system divided by the mass of the system. So our net force we just found, it's 6 newtons. Our mass is 4 kilograms. Divide all this, you get 1.5 meters per second squared. All right, so that's an analysis of what is happening on the system. So let me clear up some space here on the board. Okay, so now what I want to do is I want to find the magnitude of the force on the Wheaties box from the Cheerios box. So technically I could find either force. I could either find the force of the Cheerios pushing the Wheaties or the Wheaties pushing the Cheerios. Newton's third law tells us those forces are equal, right? And to be honest, I'm going to do both just to verify that I get the same answer. Now, I'm actually going to, first, let's do this. Let's find the force, the magnitude of the force on the Wheaties box from the Cheerios box. So to answer the given question, we're going to draw the Wheaties box. So here's the Wheaties box. We know that it's got a mass of 3 kilograms. All right. We know that it's moving along this way with an acceleration of 1.5 meters per second squared. All right. Now, this needs to be knee-jerk reaction for you guys. If you know the acceleration, automatically you find the net force. Now notice, the net force is not going to be 6 newtons. That was the net force on the system. This is what I'm looking for here is the net force on the Wheaties box. So to find that, I'm going to multiply the mass of the Wheaties box by the acceleration of the Wheaties box. Now notice, the acceleration of the Wheaties box is the same as the acceleration of the system, right? Because if you push one box, then both boxes are going to kind of move along together, right? Okay, so here we go. So the mass of the Wheaties box is 3 kilograms. Acceleration of the Wheaties box is 1.5 meters a second squared. Multiply this out and you get 4.5 newtons. So that's the net force on the Wheaties box. So now we got to identify what forces are acting on the box. Well, there's friction, and the problem told us how much kinetic friction there was on the Wheaties box. That was -4 newtons. Oops, that's an N, not a W. So we got 4 newtons acting on this thing. All right, now what's pushing the Wheaties box forward? Oh, the Cheerios. So here's the force of the Cheerios pushing the Wheaties box, right? Well, and we need our net force to be 4.5. So you go, well, net force on the Wheaties is the force of the Cheerios plus the force of kinetic friction on the Wheaties, right? So this is the force of the Cheerios, this is the force of friction, this is our net force. Let's plug in our numbers. We know the net force has to be 4.5 newtons. Force of the Cheerios is our missing force. Force of kinetic friction is -4 newtons. Add 4 newtons to both sides, and the force of Cheerios turns out to be 8.5 newtons. All right, so there's our answer, okay? But what I was saying is there's sort of a built-in check, all right? So let's do this. Let's take a second and analyze the box of Cheerios and see if we can find the force of the Wheaties pushing the Cheerios box and see if it gives us the same answer, all right? Let me clear up the... All right, so now let's look at the Cheerios box. So here's the Cheerios box. It's a 1 kilogram box. I know that it's accelerating at 1.5 meters per second squared. So the net force on the Cheerios is going to be mass times acceleration. So 1 times 1.5, that's just going to give you 1.5 newtons, right? And what forces are on it? Well, there's the applied force from Roy, or whatever that was, right? Notice that applied force is only being applied to the Cheerios box. Okay? All right, what else is there? Well, there's friction. The force of kinetic friction on the Cheerios box was -2 newtons. And then if the Cheerios are pushing the Wheaties forward, then the Wheaties are pushing the Cheerios backwards. Okay? So, same idea. Let's see. The net force on the Cheerios should be the force of Roy plus the force of kinetic friction on the Cheerios plus the force of the Wheaties. And add up your numbers. Let's see, our net force is 1.5. Force of Roy is 12 newtons. Force of kinetic friction is -2 newtons. And the force of the Wheaties is our missing variable. So subtract 12, add 2, solve this thing, and you find out that the force of the Wheaties is -8.5 newtons. And we're happy because the force is equal, 8.5 newtons, and opposite. All right, so there you go. That is a perfect example of a system of objects problem. All right,